This is a critical moment for students who are preparing to take the end of year GCE examination. So we need to start answering some past GCE questions for them. And I'm starting straight away with Pure Mathematics Paper 2, GCE Advanced Level. And I'm starting with June 2021 session. And question 1 reads, the polynomial f of x is defined by f of x, which is equal to 3 minus ax plus bx squared minus x cubed. When f of x is divided by x plus 2, the remainder is 45. Given that x minus 3 is a factor of f of x, find the values of the real constants a and b. So the first part of the equation needs the application of the remainder theorem, while the second part of the equation needs the application of the factor theorem. And we know those two theorems are closely related. The remainder theorem states that if f of x leaves a remainder r when divided by x minus a, then f of a will just be equal to r. And to obtain this a, we need to solve the equation x minus a equal to 0. So in the first part of this equation, the remainder is 45 when divided by x plus 2. So we need to start by solving the equation x plus 2 equal to 0. And if we solve this equation, we are going to obtain x to be equal to negative 2. Therefore, f of negative 2 must be equal to that remainder, which is 45. So this implies that, so we need to substitute negative 2 in this function and equate our answer to 45. So if you do so, this is what we are going to obtain. So we have 3 minus a times negative 2 plus b into negative 2 all squared minus negative 2 raised to the power 3, and that this must be 45. So this implies that 3, we know negative a times negative 2 is positive 2a plus negative 2 squared is 4, so we have 4b. Negative 2 raised to the power 3 is negative 8 times negative 1 gives us positive 8, which is equal to 45. And so if you simplify this, we're going to obtain 2a plus 4b, which is equal to 45 minus, we know 3 plus 8 is 11, 45 minus 11, which is 34. And if you divide both sides by 2, we're going to obtain a plus 2b, which is equal to 17. Let's call this equation 1. The second part of the equation says that x minus 3 is a factor of f of x. We know the factor theorem states that if f of x leaves a remainder 0 when divided by x minus a, then x minus a will be a factor of f of x. That is, if f of x leaves a remainder 0 when divided by x minus a, then we are saying that f of a must be equal to 0. And we know a is obtained by solving the equation x minus a, which is equal to 0. Therefore, if we take 3 minus x to be equal to 0, we are going to have x to be equal to 3. And therefore, we are saying that f of 3 must be equal to 0, according to the factor theorem. So this implies that 3 minus a times 3 plus b times 3 all squared minus 3 all cubed must be equal to 0. If you simplify this, we're going to obtain 3 minus 3a plus, we know 3 squared is 9, so we have plus 9b minus 3 cubed is 27, which is equal to 0. Negative 3a plus 9b, which is equal to 24. So this implies that a minus 3b is equal to negative 8. That is by dividing both sides by negative 3. Let's call this equation 2. Now to solve for a and b, we need to solve the two equations simultaneously. So this is our equation 1, a plus 2b is equal to 17. And equation 2 is a minus 3b, which is negative 8. And we can solve this equation, these two equations, by using the elimination method. If you subtract equation 2 from equation 1, here we're going to have 0. 2b minus negative 3b gives us 5b, which is equal to 17 minus negative 8 gives us 25. So if you divide both sides by 5, we're going to have b, which is equal to 5. And if you substitute this b equal to 5 in equation 1, we're going to obtain a plus 2 times 5, which is equal to 17. That is, a plus 10 must be 17. And if you subtract 10 from both sides, we're going to have a to be 7. Therefore, the polynomial f of x is given by 3 minus 7x plus 5x squared minus x cubed. That is the polynomial. And the values of a and b are 7 and 5 respectively. In the second part of the equation, we have to express this rational function into partial fractions. And since these two factors here are linear, we can express this function in a form that is 5x divided by x plus 3 into x minus 2. We can express this in a form a on x plus 3 plus b on x minus 2. And if we multiply both sides by x plus 3 into x minus 2, we are going to obtain, here we're going to obtain 5x, which is equivalent to a. Here we're going to obtain x minus 2. And here we are going to obtain b into x plus 3. Now we need to find the values of a and b. And to do so, we need to substitute suitable values for x. So I'll start with 2. So when x is 2, we have, here we're going to have 5 into 2, which is equal to a into 2 minus 2 plus b into 2 plus 3. So this implies that 10 is equal to, here is 0 plus 5b. So we are saying that 5b is equal to 10. And if you divide both sides by 5, we are going to have b, which is equal to 2. Now the next suitable value will be negative 3. When x is negative 3, we have, here we're going to have 5 into negative 3, which is equal to a into negative 3 minus 2 plus b into negative 3 plus 3. So this implies that negative 15. Here we have negative 3 minus 2, which is negative 5a, plus negative 3 plus 3 is 0, so we have 0b, which is just 0. So if you divide both sides by negative 5, here we're going to have 3, which is equal to a. Therefore, we are saying that 5x divided by x plus 3 into x minus 2 is equivalent to a, which is 3, divided by x plus 3 plus b, which is 2, divided by x minus 2. There's another simpler method of doing this without passing through these steps. And this method works well only with linear factors like these ones. This method is called the Covarial Method. So this is what we have to do with this Covarial Method. So we have x divided by x plus 3 into x minus 2. So we say this is identically equal to, what we need to do here is to cover this factor, x plus 3, and we substitute negative 3 in the remaining part of the function. So if you substitute negative 3 here, we're going to obtain 5 into negative 3 divided by negative 3 minus 2. This gives us negative 15 divided by negative 5. And if you simplify this, we're going to have 3. So this is equivalent to 3 on x plus 3 plus, then we cover this and we substitute 2 in the remaining part of the function. If you substitute 2, this is what we're going to obtain. 5 into 2 divided by 3 plus 2, which is the same as 10 divided by 5, and this is 2. So this is 2 divided by x minus 2. So it's a very simple method of expressing rational functions with linear factors at the denominator into partial fractions. So in the next presentation, I'll be solving the second question, question 2. And so if you have not yet subscribed to this channel, please make sure you do so immediately and do not forget to turn on the notification bell